Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at vector projections. The idea here is this: we have a vector A and a vector B. We can decompose A into two parts. The part of A that's parallel to B, called the vector projection of A onto B, and also the component of A that is perpendicular to B, called the vector rejection of A on B. So let's start by looking at an example. So we have A equals 4i plus 5j, and B is the vector I plus j. We first calculate the scalar projection of A on B according to this formula. So just make sure you get the A's and B's the right way around. The vector onto which you are projecting is the one for which you find the unit vector. So to find the unit vector in the direction of B, we first calculate the magnitude of B. You probably know how to do this by now. Square root of 1 squared plus 1 squared is just root 2. So the unit vector in the direction of B, we just take each component of B and divide by its magnitude. So the unit vector in the direction of B is 1 over root 2i plus 1 over root 2j. To calculate the scalar projection, also called the scalar resolute of A on B, we just take the dot product of that unit vector and our original vector A, which was 4i plus 5j. So to calculate the dot product, remember, we just multiply the two x components, multiply the two y components, and add up those answers. So we get 4 over root 2 plus 5 over root 2, which is 9 over root 2. So it's called the scalar resolute or scalar projection because your answer is a scalar. This number is just to indicate how much of A is in the direction of B. So now we're going to calculate the vector projection of A on B. This answer is actually a vector. We're finding this vector here. So we take our scalar resolute and multiply by the unit vector B. So the scalar resolute we found previously was 9 on root 2, and we found that the unit vector B was 1 on root 2i plus 1 on root 2j. So multiplying these two together, it's just scalar multiplication. We get 9 over 2i plus 9 over 2j. So now we will calculate the vector rejection. That's the component of A that's perpendicular to B. So note from the head to toe rule for adding vectors, this vector plus this vector equals this vector. A is just the projection plus the rejection. So the vector rejection is just this vector minus this vector. So we take our vector A, which was 4i plus 5j, and we simply subtract the vector we just found, 9 over 2i plus 9 over 2j. So this is a simple vector subtraction. We just subtract the two components. We get minus 1 over 2i plus 1 over 2j. And notice if you add this vector and this vector, you get this vector. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.